Welcome. This is our presentation on the geometric Brownian model, which will be done by Micah, Anthony and Jamie. Just the contents of the presentation. First we'll talk about the history of the Brownian motion, then we'll talk about explaining it and then applying it to stocks, while Jamie and Anthony will go over the model and the VBA involved for doing it. So since the inception of financial markets, people have always tried to predict the future price for obvious reasons, as if we can predict the future price, we're able to make profits. However, no one really knows. With the technology and knowledge we have on financial markets, we can only make educated guesses on where the price is going to go, whether it's going to go up or down. Therefore, mathematicians have tried to develop models that predict price paths in order to make profits. So the geometric Brownian motion assumes stock prices are expected to follow an exponential curve in the long run. That means that stock prices, as time goes on, firms are able to grow their value and sales and operations, and eventually their growth rates to make an upwards curve. However, in real life examples, we can see that random fluctuations follow this curve, this exponential curve, as buyers and sellers constantly move the price up and down. So this idea of the motion is the Brownian motion by Robert Brown in 1827. He founded this when he analysed the motion of 5 particles colliding with 800 particles. As you can see on the right there, the particles collide randomly and go in random directions, and this sparked the idea of random movements in stock prices. So when the theory was applied to stock prices, this is done to help try and explain these random fluctuations we see on the exponential curve. Stock prices can be said to be random variables following a normal distribution as buyers and sellers push the prices up and down each day. There is, however, a few assumptions involved in the Brownian motion. First of all, the Markov process, where only current prices are relevant for predicting future prices. So prices in the past are not relevant for future prices. Stock prices are also continuous in time and value. They are continuously compounded return for a stock is normally distributed. And lastly, the short period return on a stock, so a daily return on a stock, is normally distributed. This means daily price changes in stocks are likely to be in a similar ballpark, but there is a slight chance of a crash or spike in the stock price. Now, Jamie will be going over just end it. Yep.
Okay, so here we have a set of data with 3 variables: the stock price, the certain and uncertain. The data ranges over 100 days, and it slowly increases at an exponential growth. Okay, so here we have the graph, which is the output of the data that I was talking about before, and we have the stock price starting at $20 right here, and we have the data set, which is 100 days long. So first off, we have the stock price, which is the blue line, and underneath is the certain component line in the red. And the certain component line is a average with no fluctuations over the 100-day period. And then the stock price has the Brownian motion, the random fluctuations over the 100-day period. And then underneath is the green line, which is the uncertain component. And this line is literally just the blue line minus the red line. Right, so here we have the variables. The variables directly change the data set, so when you change the numbers, they change the data set. We have the stock price at the top, the default settings right now there, and then we have the time increment, expected return and volatility, and also the N, which is the number of periods. Okay, so we have a set of buttons that are attached to the variables. We have stock price, which is set at 20. Can we change that to 10, please? And then we have time increment set at 10, we'll leave that there. Expected return, we'll change that to 0.3. And we have volatility lossable, and we'll change that to 0.25. Okay, so after changing all those variables, we click refresh graph. And as you can see here, the graph changes according to the variables that we just adjusted. And we have a whole new set of data after pressing the refresh button. As well as being able to change the variables manually, we have the refresh button, which we can click multiple times. And each time we click the refresh button, it creates a randomized Brownian motion data set, as you can see over here, each time it's changing. And each one's different. And then also we have a second button which says reset default, and the reset literally just resets it to the default numbers that we were given. The buttons also have a error filter, so the buttons cannot, if you enter punctuality, letters, or a non-numeric value, or a negative stock price, the error filter will stop it from working. So here we have an example of entering letters. So the word 10, click OK. So the word 10 will not work if you put it into the variable code. This time we'll try using a negative number in the error filter. So we have negative 20 right there, and again we see that it doesn't allow the negative number. And then again we'll try punctuality. So any sort of punctuality doesn't work as well, and we can see the filter doesn't allow.
Alright, so here we have the code for our model. So let's start in the simulation sub. So this is the code that will be run when you press the refresh button to create a new graph. So first what it's going to do is create some variables, S0, DT, MU, vol, N, and K. So these are the variables that are used in calculating the stock price. Next we have sold, S new, cold, C new, U new, and R draw, which are variables that will also be used in calculating new stock prices in a loop later on. So next we have dim, row, offset, and I. These are used to count our loop and also to find where we are in the cells to draw to get the variables that we need. So next we're going to move on to the chart variables. So you can see the comment there, create chart variables. So what this does is creates all of the variables we need to draw the chart that you saw earlier with the nice three colored lines. So CO is a chart object, CT is a chart, SCL is a collection of our series, and our three series are SIR S, SIR C, and SIR U, which are basically the series of our stock price, our certain component, and our uncertain component. Next, let's move on to the variables for the set buttons. So these are the buttons that will allow you to create new values to use. So stock P is our container for the stock price that the user wants to use. Step S is for the step size. Expect is for the expected return, and volatile is for the volatility. So these are the values that the user wants to use. So next we're going to set S0 is equal to cells 1 and 2. So this was part of the original code. So all of this code here basically calculates the stock price, the certain and the uncertain component. So this part here is, if we scroll down a little bit, so what we have here is a loop. So for I equals 1 to n, so it's going to run through every value of I, and I is just going to count up to n, and n is 100. So it's going to go through 100 times and generate 100 stock prices. And this is the code over here that actually calculates the values of those lines. So if we scroll down a little bit further, please, we can see this is the part where we've added the chart, right? So we're going to set our chart object to be chart object, and it's going to start at J2, and it's going to be 1,000 wide and 400 tall. So now we're going to set the name of the chart object to CO name. We're going to set the chart, and now we're going to draw the chart. So if we scroll down a little bit further, what we can see here is that with the chart, we're going to say that it's going to have a legend, so we're going to use dot legend equals true, and it's going to have a title, right? So that title is defined here. The chart title is Brownian Motion Visualization, and what we've allowed it to do is to set the original price, the starting price, to be shown because it has and S0. So every time you draw a new graph, it's going to show what the stock price you're using is. Next, we need to define the series. So these are the three series, those three lines that you see on the graph. Now we need to draw each of these lines. So if you scroll down, please. Yeah, a little bit further. Cool. So here we can see a bunch of width and end widths. So what this does is first it's going to use series S. So this is the stock price line. It's going to set the name of that line to stock price so that the legend in the graph says stock price next to the blue line. So that helps you to visualize what's actually going on. Next, the X values are basically going to be all of those numbers that were in the data set it's basically just N counting up from 0 to 100. And the values are the stock price values. These are the Y values that we're going to graph. And the chart type is going to be a line graph. That's what the Excel line means. Right, so then we move on to the certain line, and it's basically a complete repeat, except that this time we've shifted over from 5 to 6 to allow us to move and get the next set of data. And we've also changed it from stock price to certain component because now we're graphing the certain component. So if we scroll down, repeat it again for uncertain, and if we scroll down a bit further, that's the end of our sub for simulation. So that's what's going to happen when you press the refresh button. So let's move on to the reset button. So when you press the reset button, it's going to run this macro here, which is called sub reset. And all this does is sets all of the values back to the original. So B1, the cell B1, its value is going to be changed back to 20, B2 back to 10, B3 back to 0.2, B4 back to 0.3, and B5 back to 100. The user won't actually be able to change N equals 100, so it shouldn't really need to happen, but we've added it just in case someone messes with the Excel sheet when they're not meant to. We've made it that the user can interact with the model completely only using buttons and the input boxes that come up so that they don't have to change anything in the Excel sheet. So if we scroll down a bit further, we have a series of subs for setting the price, the stock price, the step size, the volatility, and the expected return. So these are all mainly carbon copies of each other, but for the set price one, what's going to happen is the stock P, which is our variable for the stock price that the user wants, is going to be equal to the input box, and it's going to ask, please enter a new stock price. So the user is going to enter a new stock price. If the stock price is greater than 0 and it is numeric, then it's a good stock price to use, right? Which means it's not negative, it's not punctuation, and it's not letters. In that case, we want to set B1 dot value equals stock price, which is going to change our S0 value later on when we press the refresh button. If they don't put in a good number, so if they put something in that's negative, if they put something in that's not a number, what's going to happen is a message box will come up. You must enter a numeric positive and non-zero stock price, and nothing else is going to happen. So the stock price won't be changed. It's just going to be left at the previous thing they use. And then, yep, for the set step price, it's the exact same thing as stock price, except this time we're working with the cell B2, and we're not using stock price anymore. Now we're using step size. So instead of stock P, we're using step S. And then if we scroll down, set expected return, the exact same thing again, just with different variables. And if we scroll down to the last sub, this is to set the volatility. So sub volatility, you can set what you want the volatility to be here. Right, well, that's all for the code. Thanks for listening to our presentation. Cheers.